Hello everyone, in this tutorial, we will implement a job system for our Boids. Picking up where we left off last time, we had 1000 fish with the same transform moving in circles. First, we will turn the tick method into a job. For that, we need a few packages. Open up the package manager. Install the entities and burst packages. They will provide the job system structs that we need. Let's create a new job system. Declare a new struct and have it implement the iJob parallel for interface. Also add the burst compile attribute above the struct. This will tell the job system to use the super fast burst compiler to efficiently parallelize our code. Next, change the tick method into a coroutine. This will allow us to schedule our job and then wait for it to complete asynchronously. Start the coroutine in awake. Let's also add a new serialized field for tick delay. This will determine the tick rate of the Boid simulation. In the tick coroutine, enter an infinite while loop and add a yield return statement. Now this tick routine will run as long as the game object that this script is attached to exists and will conveniently exit the while loop on its own when the game object is destroyed. Let's create a new update job and then schedule it. The iJob parallel for schedule method takes two parameters. First one is the number of items that will be processed in parallel. The second one is the number of items that will be processed per thread, also known as the batch size. These next two lines are very important as they enable us to maintain a high frames per second. We want to wait until the job has completed processing all the Boids and then we want to mark the job as completed. You could remove the wait until block and just complete the job after scheduling it. This will block the main thread and reduce your frames per second significantly. Now let's work on the job. Add a native list of matrix 4x4 for the Boids. We will also need the move speed of each fish. The iJob parallel for does its processing in the execute method. This method takes as argument the index of the Boid. This method will be run across multiple threads by the job system and the index parameter will be filled based on the first argument of the job.schedule call we made earlier. So now we can process each Boid in parallel. How neat! Now add the former tick logic in execute. We will use float 3 instead of vector 3 as it is intended to be used inside jobs. We also need the delta time for the position update. Make a new variable in the struct for that. Lastly, we need to update the output matrix 4x4. Now, we need to do one more thing to enable this job to run in parallel. We need to specify that the Boid transform list will be written to in parallel. Add the native disable parallel for restriction attribute. Let's pass in all the arguments into the job. For the delta time, we need to calculate the time elapsed since the last tick. Also provide the other arguments. Create a native list in awake and dispose of it in on destroy. We need to do this because native list does not automatically dispose its memory. We also need to resize it before scheduling the job and copy all the Boid information into it. I also make the job handle, which is the output of the schedule call a class variable and await its completion before disposing the Boid list. This is necessary in this order because if we dispose the list before the job is completed, the job system will complain that the list we are reading and writing to inside the execute function is not allocated. This makes sense since we have manually allocate and deallocate this type of data structure. This means that we allocate the Boid list in awake. We use persistent allocation to tell Unity that this list will remain allocated for the entirety of the lifespan of this game object. Then when the game object is destroyed, our code will wait for the job to finish if there is one scheduled and clean up the Boid resources. Before we create the update job, let's update the Boid native list to contain our Boid information. Do this by updating the capacity of the list, which the amount of memory allocated for this resource. Then create a temp native array from the fish TRS with temporary job allocation. This type of allocation tells Unity that we will only need its memory temporarily. Copy from the temp array into our Boid native list container. This operation could take a lot of time. So I wait for a Unity fixed update before proceeding. This way our coroutine isn't blocking the game engine for too long. We will also dispose the temp array after copying. But do this before waiting since the temp job allocator expects to be disposed within 4 frames. Finally, provide the fish native list to the job. After the job finishes, we need to tell the fish rendering list about the new transforms that were calculated by the job. Basically, we need to iterate over each Boid and copy its data. We can optimize this by using system. Threading.tasks.parallel to run the copying code asynchronously across multiple threads. This makes a significant difference in performance. Great. Now save the changes and populate the new fields in the editor. When we press play, we can see the fish moving. Yay! The update job works. It is computing all 1000 fish in parallel. But of course all the fish are overlapping. We will add some intelligence to their behavior in the next video. I created a FPS counter so I can see how the Boid AI impacts the frame rate. Here is the final script. Attach it to a Text Mesh Pro text field. Copy this code. That's it for this tutorial. See you in the next one.